ish. Okay, let's go ahead and do number 6. So now I have log of 45. Let's see how fast you guys can enter these into your calculator. Log of 4.5 divided by log of 4. What'd you get, Tony?
108.
Sorry, what was that?
108.
Beautiful, I agree. Okay, let's take it to the 4th power. So I want 1, 2, 3, 4. Ooh, this one's gonna be kind of interesting. Is the 6 gonna bump the 9 up to a 10?
No.
Yes, it is. So this would actually change from 49 to what? 50. Yeah. So our decimal is actually going to be 1.0850. And yes, you want that 0 on the end. That tells us, yes, I rounded to the 4th decimal place. Okay, what do you notice about number 7? What is missing? Yeah, the base is missing. Okay, now here's the thing. Do we have a couple of numbers in math that like to be invisible? Mathematicians just don't like writing them? Yeah. Okay, so with logs, whenever you see an invisible base, guess what number it is? Let's see if you can guess. Gabe?
A 1.
Very close. It's not a 1, actually.
0.
It's not a 0. Put the 1 and the 0 together. What does that make? It actually makes 10. So whenever you see an invisible base, it's actually a 10 there. Log base 10. Okay. Okay. So guess what? In your calculator, everybody look at your calculator. With our log button, does it let you choose a base? Or is it just log? It's just log. So guess what? That button in your calculator is log base 10. Oh. So guess what? We don't even need to do any division here. We can just simply type in what is log of 11. Enter. Oh. We didn't even have to divide by anything. It was just log of 11. Okay, so now let's take it to the 4th decimal place. 1, 2, 3, 4. 9. Gonna bump the 3 up to a 4?
Yeah.
Yep. So then our decimal becomes 1.0414. Oh. So if you don't see a base, guess what? That makes your job easier. Just type in log of that number. Woohoo! Love it. Love calculators.
We all.
Yes, we do. Okay. Let's look at 9. Go straight to 9 then. Maybe I'll have you do 8 and 10 on your own. What's my invisible base? 10. Do we have to do the log of something divided by the log of something? No. What can we just type in our calculator?
The log.
Log of 2. You can literally type in what is log of 2 in my calculator. Log 2. You get the same answer? Log of 2. Let's take it to the 4th decimal place. Look behind. Is this 2 going to bump the 0 up to a 1?
No.
Nope. If it's 4 or below, it stays. So we have to write 0.3010. 0.3010. Okay, let's get some more practice. Try number 8 and 10 on your own. Just punch them into a calculator. I'll do it as well, and then we'll compare answers. Okay, so you're doing 8 and 10 on your own. I'm going to freeze the screen, and I'm going to do it as well. Ready, go. See if you can round it to 4 decimal places as well. See what you get. Okay, let's take like 10 more seconds. We'll compare answers. All right, let's compare. How'd we do? Number 8, I got 0.0201 after rounding.
That's what I got.
That's what we got. Okay, check and make sure. Did you put log parentheses 1.014 divided by log parentheses 2? Yep. If not, maybe just check. Maybe you missed closing a parentheses. Got to close those parentheses. Okay, then number 10, after rounding, I got 1.8074. Get the same?
Yeah.
Nice.
Wait, what did you get for 9?
0.3010. Nice.
Can you go back to 10?
Yep, absolutely. How are we feeling with evaluating logs? I can just punch them into a calculator, see what we get. How are we feeling? Show me a fist of 5. And I could do this in my sleep. I could use a little help on the review today, probably. Cool. I like it. 3s and 4s, that's pretty good.
Yep.
This is tough stuff. All right. Okay. 11 and 12. Are these guys in log form? Do you see the word log on those guys? Nope. They're in exponential form, which is great. So we are going to graph these. Okay, these are the opposites of our logs. Which letter, X or Y, is in my exponent spot? Which one's in the exponent spot, X or Y? The X, okay? So we're gonna choose values to plug in for X. Okay, I'm gonna do my -2, -1, 0, 1, and 2. Okay, remember that a table always works when we're graphing these guys. So I'm gonna choose these numbers to plug in for my power, see what we get for our Y. Okay, well let's start with our our positives. So if I have 2 as my base, what is 2 to the power of 2? What would I get out? 2 squared. 4. What about 2 to the power of 1? Don't overthink it. What's 2 to the first power? Nice job. 2. What is anything to the 0 power?
1.
Oh, you guys are good. And what happens when I have negative exponents? It just
Flipping over.
flips. Beautiful. So for my -1, instead of 2 over 1, it becomes 1 over 2. And instead of 4 over 1, it becomes
1 over 4.
1 over 4. Oh, you guys are good. Okay, these become our coordinate points. That's why I'm putting my little parentheses around them. Let's go ahead and put these on our graph. Okay, so first it wants me to go to -2 and then up 1/4. Just barely up a little bit. Then -1 up 1/2. A little bit higher, teeny bit. Whoops, might want to be able to see it. 0 up to 1. 1 up to 2. And 2 up to 4. Connect those guys with your little, kind of looks like a ski slope kind of thing. And there we go. Just graphed an exponential. Good on number 11. Moving on to number 12.
Yeah.
Let's do it. Okay. So instead of 2 to the x, like on number 11, it is now 3 to the x. Okay, but we're still going to do the same thing. Give yourself a table. My x is in the exponent spot, so we want to plug in values for x. Okay, same values. Gives us some negatives, gives us a 0, gives us some positives. Okay, so let's figure out what we would get. Let's start with our positives first. So this would be 3 to the power of 2 what would I get out? 3 squared. Super close. 3 times 3? 9. What about 3 to the power of 1? Just 3. Anything to the power of 0? 1. What happens with the negative exponents? It flips. So instead of 3 over 1, it becomes 1 over 3. Instead of 9 over 1, it becomes... Look at you guys go. There are my parentheses for my coordinate points. Let's go ahead and put them on our graph. So it wants -2 up 1/9, just barely up a little bit. -1 up 1/3. 0, 1. Notice we always get a 0, 1, no matter what our base was, right? If with 2 to the x, it was still 0, 1. 3 to the x, it was still 0, 1. Keep that in mind. Then I have 1, 3. And 2 all the way up to 9. Same shape because it's still an exponential. Still get that ski slope. Nice. Look at you guys graphing exponentials.
It's tiring.
It's tiring. Yes, it is. Oh, I didn't write 9 right there. Okay. Okay. Flip your page over. Are these guys exponentials or are they logs? They're logs. And for some reason on this program that I make the notes, it doesn't let me simplify it down anymore. But we're going to anyway. Okay, and so for number 13, instead of all this extra mumbo jumbo, cross off the extra mumbo jumbo, we're just gonna do y equals log 3 of x. We're not even worrying about that mumbo jumbo. Okay? So, on our starter, our step 1, what did we have to do very first? Look at number 4. What did we have to do?
We had to do it to the y.
Beautiful. We had to convert it from log form back to exponential form, right? We had 4 to the y equals x. We're going to do the same thing for number 13. So, now it becomes 3 to the y equals x. 3 to the y equals x. Okay, now, which letter is in my exponent spot now, x or y? Y. Okay, so now, instead of plugging things in for x, we're actually going to plug them in for y. But guess what? We're going to use our same values. You could actually choose whatever values you want. These ones are just usually easier to graph. Okay, but let's see what we get, just like on our graphs we were just doing. So, 3 squared, what did we decide? If I plugged in a 2 for my exponent, what would I get? 3 to the 2nd power. 9. What about 3 to the 1st power? 3. Anything to the 0 power? 1. What happens with the negative exponents? It just flips. So instead of 3 over 1, it becomes 1 over 3. Instead of 9 over 1, it becomes
1 over 9.
And you're like, wait, Mrs. Campbell, didn't we just do that? Notice how cool this is, right? Exponentials and logarithms are inverses. They're opposites of each other, right? Right. Okay. Look at number 12. Right? We have the same exact numbers. What's happened? They've just been switched. That's all it is. Okay, these are still our coordinate points. We're still going to graph them, but this time it's going to be a log graph because it's been switched. Okay, so it wants you to find 1/9 on your x. So that's like barely past right here. Then it wants you to go down to -2. So that's right there. like 1/9-ish down to -2. Then it wants 1/3, just a little bit farther, down to -1. Now it wants 1/0, right there. Then 3 up to 1. And 9 would be this next spot right here, but it's going to go a little off the graph. That's okay. 9, 2. And there's our log. Kind of the same basic shape as an exponential. It's still like that curvy. Instead of really tall, though, it just kind of gets really flat. Wow, Mrs. Campbell. Math is so cool. Inverses are just so awesome. I don't want to go home ever. I know. I know that's what you're thinking. Okay.
No, that's not what I'm thinking. We just want to go to sleep.
Me too, believe me. Okay, so let's get rid of number 14. Get rid of the mumbo jumbo. We're just going to do log base 2 of x. And I will tell you, maybe put a star by this one. Like this one might be the exact question on your review and your test. Put a star by it and then just graph these same coordinate points. Yeah. Yep. Okay, so first thing we had to do was take it out of log form and put it into exponential form, right? So we're going to do the same exact thing. So 2, grab your y, would equal x, meaning 2 to the power of y would equal x. Which letter is in my exponent spot, x or y?
Why?
Y, so that's why we're going to plug values in for y. Same values. So let's see what we get. Alrighty, if I were to plug in a 2 for my exponent, that would make it 2 squared. What is 2 squared?
4.
4. What is 2 to the power of 1?
2.
2. What is anything to the power of 0?
1.
What happens with my negative exponents? So instead of 4, or excuse me, we're on -1. Instead of 2 over 1, it becomes 1 over 2, or 1/2. Instead of 4 over 1, it becomes 1 over 4. Oh, wow. That's so cool. We just did that too. But they've just been flipped. Okay, let's go ahead and put these on our graph. So it wants me to go over 1/4, just barely over, and down to -2.
2.
Then it wants me to go over 1/2, again, just barely over, not quite to 1, and then down to -1. Then we have 1, 0. 2 up to 1. 4 up to 2. Like I said, that might be the exact problem on your review and on your test. You're welcome. Okay, I think you get the idea, right? These log are literally just the opposites of 11 and 12, right? 11 and 12, they've literally just been flipped. Yeah, cool, huh? Okay, so we're going to go ahead and skip 15 and 16. I want you guys to have some time to work on your review. Ask me questions if you need it, because Friday is a shorter day. About an hour and 10 minutes classes are, right, to take your tests. So go ahead,